So today this is the third lab, okay, and in this lab also we are going to learn one method. Probably in the last lab you have learned one method to solve nonlinear equation. So in this lab also we are going to learn how to solve nonlinear equations, and today we are going to deal with two methods. So both of them are iterative method. One is fixed point iteration method. So one is fixed point iteration method, another is Newton-Raphson method. So can anyone tell which equation will be told as nonlinear equation?
So linear equation is any equation that follows the rules of homogeneity, sir, and superposition, sir, I guess.
Yes, actually those are the properties. You are right. So these type of equations, okay. What I want to just tell you, any equation, suppose like this, y is equal to suppose 2x plus 3, okay. So where the degree of each variable, okay, power of each variable is maximum power is 1. So there, what type of equation? Linear equation. But if something like this is there, okay, x square plus 3, so this is nonlinear equation. Again, if something is like this, e to the power x exponential, or something like this, x cos x, okay. So all these type of equations are nonlinear equations. So actually these type of equations we are going to solve with iteration, method of iteration, okay. And today we are going to learn two methods. So first one is fixed point iteration method. So here the steps have been given how we are going to get the solution with the help of fixed point iteration method. So the steps are very easy, okay, but one example will make you more clear, okay. That's why directly I am going for one example. Okay, Tasin. Okay, so this lab, okay, this lab sheet is very well organized, okay. That's why I will be following totally this lab sheet, okay. So whenever I may just go for some explanations, but all the explanations will be based on this lab sheet, okay. And I will go through each and everything of this lab sheet, okay. So please follow me. So let's see one example. So as I told that I will ask very simple questions to these students. So roll number 320, are you there? 320.
Yes, sir.
So can you kindly tell what type of equation this one is? This one?
It's a quadratic equation.
Yes, that's a quadratic equation. Linear or non-linear?
It's a linear.
It's a linear, isn't it? Can
Yeah.
anyone tell what type of equation this one is?
So it's non-linear.
Non-linear. Why?
So x has power 2.
Yes.
Exactly.
Actually,
Because
if I if I want to find the solution of this one, then what I need to do? Now I am dealing with fixed point iteration method. Fixed point iteration method. Method, okay. So here, suppose if I want to, so if you don't have any question, then please mute your microphone. So if I want to solve this, please mute your microphone if you don't have any question. So this is the equation, nonlinear equation that I want to solve. Okay. So suppose this is fx. Fx is equal to x square minus x minus 1. Okay. So I want to solve this nonlinear equation. For this, at first, what I need to do, I have to just write this equation. Suppose x square minus x minus 1 is equal to 0. I have to separate x from here. How? X is equal to, suppose here, actually x square is equal to x plus 1. Okay. So now x is equal to 1 plus 1 by x. Okay, just I have rotated them. Okay, nothing else. Just 1x has been taken here. Okay, both the sides have been divided by 1x. Okay, so you can see I have separated x. So from this fx, what I have done, I have separated x. Okay, so you can see x is also one function of x. Okay, so gx. So x is equal to gx. So from this fx, what we have done, we have separated x and we have found x is equal to gx. So these are the two things that I am in need to do. So up to this, are you okay? Everyone?
Yes, sir.
Yes, sir.
So at first I need to do this one, okay? Then what I have to do, we have to make this one general equation, okay? So using this equation, I will just find my consequent values of x. How? Suppose from here, I will just arbitrarily consider one value of x. Suppose initial value of x, any initial value I will take, okay? Just initial value of x. So after this, what I need to do, I have to find another value of x because I don't know whether this solution is okay or not. Okay. So what I need to do, I need to find another value of x. So how can I do that? I will just do it like this. X is equal to, I will just use this equation, 1 plus 1 by x. But here the value of x will be actually my previous x. What is my previous x here? Can anyone tell?
So 1.6.
X0, isn't it? This is the initial. Next time, during my first iteration, suppose I have taken like this, x1, okay? So now, I will just check. I will check whether this x0 and x1, they are close to each other or not, okay? If they are not close to each other, that means the solution is not merging. Then what I will do, I will find another value of x, suppose x2. How I am going to find x2 then? Using this equation, 1 plus 1 by x. But here, what's the value of x?
X1.
X1, sir.
x1, okay. So now, you will be able to see that now x2 is comparatively better solution, okay. How can I see whether that's a better solution or not? I will just check the difference between these two. Okay, that means x1 and x2. You will be able to see this difference. If this difference was 10, then this difference x1 and x2 will be suppose 5. Okay, that means is merging, is converging. Okay, so in the next step, if I want more precise result, what I will do, I will again use this equation. I will use this equation. Okay, x plus 1 by x. Here previous x is actually x2, so x2. Now again I will check whether this is better or not. Then I will be able to see that the difference between them is comparatively less. Okay, so difference is less. If the difference between them is less, then the error is comparatively less. Okay, so different types of errors are there. You have learned already. Okay, approximate error, relative approximate error, all those things are there. So any one of them, based on your desire or based on the problem, it will be told that your maximum possible range or maximum possible error, suppose relative approximate error is something like this 0.0001. So what you need to do, you need to go on like this. Okay, you need to go on like this at one stage, suppose at x99. Okay, so during dash time, you will be able to see the solution is so much good that before this one actually is x98. Okay, so the difference between x98 and x99 will be very less. Okay, so at that time we have got our solution. Okay, so let's clarify this one based on this one. Okay, so the idea is very simple. Okay, very easy thing. Okay, now let's see this one. So my first job is what? From this fx, my first job is to separate x. Okay, so separate x in such a way that this is my gx. Okay, then what I will do, I will find one general equation. Okay, you can see this is the general equation. From here I will find a general equation. Okay, so xn plus 1 is actually my present value of x. Okay, and xn is actually my previous value of x. Okay, so already I have shown this. From this equation we will just find a general equation. Okay, now after this what I will do, I will just find any arbitrary value of x, initial value. Okay, so initial value, so here is shown initial value as x1, no problem, but in my case where I have shown, I have used initial value as x0. It doesn't matter what you will just consider, that's actually your initial value is. So now I don't know whether this 2, because this is totally one approximation, I don't know whether this 2 is actually my solution or not. Okay, so what I need to do, I need to get some better solution. Okay, for that what I will do, I will just go for iteration. Okay, how? I will find another value of x, that means x2. How? With the help of this equation. Okay, with the help of this equation we are going to find x2 is equal to 1 plus 1 by x1. x1 is the previous value here, and blue one you can see x1 is 2, so 2 has been given here, so you can see the new value is 1.5. now see what's the difference between them. The difference between them is 0.5. Okay, so if I want more precise result, what I need to do, I need to go for another iteration. Okay, so now I want to find x3. So x3 is equal to 1 plus 1 by x2 as per this equation. So now if I put all those values, I can see the result is something like this. So you can see the difference between x2 and x3 is almost 0.166. Okay, so now I want better, more precise result. That's why what I need to do, I need to go for more iteration. Okay, so let's go for another iteration. x4 is equal to 1 by 1 divided by plus 1 by x3. So green one is the x3 here. Okay, you can see green one is the x3. So x3 has been given here. So after calculating the values, we can see that this is what actually my result is. Okay, so now what's the difference between x3 and x4? This is around 0.066. You can see the result is being better. Okay, so in this way I will go on. Okay, up to a specific number I can go on. Okay, suppose here they have gone for 6 times. Okay, up to x6 they have found out. Okay, so you can see the value of x6 is something like this. Okay, and if I find the difference between x5 and x6, then you can see it's almost 0.01 or less even. Okay, so you can see gradually it's merging towards the solution. Okay,
I have
so
one small question, sir.
yes, please.
Yes, sir. Sir, here, sir, we are doing up to 6 iterations, right, sir?
Yes.
So we are fixing it, sir. Like when we write the code, sir, how will we know the accuracy of the 6th iteration is the one we are requiring? Like when we do it by hand, we can look at the value and determine it is the 6th iteration and this satisfies my level of accuracy. But how will I ensure it in the code, sir? It's like
Yes.
there. Yes.
Yes, I have understood your question. You are Tasil.
Yes, sir. Hello, sir. Assalamu alaikum, sir. I joined a little late, sir. Like
Yes.
after that. Yes.
Your voice. I know your voice.
Yes, sir. Okay, sir. Okay.
Okay. So you are probably your batch. Okay. So I have taken most of my classes because I am new. Okay. Whenever you have started IoT, at that time also I have started IoT as a faculty member, and from the beginning I am taking classes. That's why name as well as faces, all of them are of all of you, I can recollect. Okay.
Yes, sir.
So your question is actually here what has been shown, one specific number of iteration has been mentioned. Okay, iteration number is mentioned. Okay, so in our code, in the MATLAB, we are going to demonstrate for actually Newton-Raphson method, the second method. This method is not going to be demonstrated in the MATLAB, but actually two things are there. What we can do, we can specifically mention the iteration number. Suppose 10 iteration number. Okay, so at that time, I can just find this arrow to see how they are changing, nothing else. Okay, but if I want any specific, okay, any specific error limit, if I want to provide any specific error limit, suppose relative approximate error, okay, absolute relative approximate error should be less than suppose 0.00 or 10 to the power minus 5. Okay, even it may be percentage. Okay, if I want to do something like this, at that time I will not be able to mention the iteration number. Why? At that time I will just check the error after each and every iteration. Okay, I will check error after each and every iteration. Suppose x new minus x previous divided by x new. Suppose if its percentage 100. Okay, I will check every time. I will check whether this is less than 10 to the power minus 5 or not. If it's less than 10 to the power 5, then I will go for the solution. Okay, then the value of x new is my solution. But if it's not occurring, that means whenever I am finding this error and it's not less than 10 to the power minus 5, at that time I will go for iteration again. I will find another value of x. Okay, suppose if x new was 2, then another x new I will find x3. Okay, like this, no problem.
Okay.
Here, this one, okay, this method is actually in your lab sheet. Okay, I am going to elaborate this one in your lab sheet, no problem. So here, do you have any problem here regarding the idea, how they are giving me the solution?
No, sir. The idea is clear, sir.
Idea is clear. Anyone? Any problem? I know one foreign student who is very good, was very good during my class. Yeah, Harun Ba. He was very
Yes.
serious. So are you understanding?
Yes, it is a simple
Okay,
thing.
very good. So, you know, different methods are there, but there are different problems with different methods, unfortunately. Okay, so different limitations are there. Okay, for each and every method. Okay, so that's why different methods have come. Some are very efficient. Okay, some takes only 2 or 3 iterations to give the solution. Okay, so Newton-Raphson method we will just show you later on, inshallah. So whenever I will run the code, then you will be able to understand that within 2 or 3 iterations it's giving the solution. Okay, sometimes it takes some methods take comparatively less time. Okay, some method takes comparatively less number of iterations. Okay, some can give the solution of some type of equation and some cannot give the solution of some type of equation. So advantages and disadvantages are there, some limitations are there. So one limitation, one problem of this equation is you have to choose the value of x in such a way that, so can you remember at first we were just specifying fx, then from fx we used to find gx, isn't it? X is equal to gx, we used to find this one. Okay, so whenever I am going to find this x as a function of gx, then I have to consider one specific condition. What's that condition? That condition is the derivative of, derivative means dgx divided by dx. This the absolute value of this one should be less than 1. Okay, this is one condition. If this condition doesn't fulfill, then my solution is not going to merge. So there are different ways in which I can express my x as a function of x, that means gx. Okay, so at the right side, you can see they have found out x in another form. Both of them are saying, okay, x is equal to gx, x is equal to gx, x is equal to gx. But here, this condition is not going to be fulfilled. Okay, that's why this solution is not going to merge. Okay, so before I go for the iteration, so during each iteration, what I need to do, I need to check whether this condition is being fulfilled or not. Just, do you have any problem with the idea of what is being told here?
No, sir. This is fine, sir.
Okay, very good. Now, I told that what I'm doing here is actually the elaboration. Okay, my target is to make you understand this lab sheet. Okay, so now at first, what I will do, at first I will find fx. Okay, so here in first step, from fx, what I need to do, I need to separate x.
Sir, separate x, make it subject.
Yes. So I know it. So I know it. Then what I need to do, I need to estimate new root. Okay. How I am going to estimate? I am going to estimate. Okay. Let me show here. How I am going to estimate from here. How we have estimated? Can anyone tell how I have estimated? I have just made this equation as the common equation. Okay. Actually, this equation means x is equal to gx. I have just made this equation as the general equation for all my upcoming value of x. So from x0, if I want to find x1, what I have to do, I have to simply write this one. This one is actually gx, but the value of x is actually 0, isn't it? So to find x1, what I need to do, I need to put gx0. To find x2, what I need to do, I need to put x1. So it's not required for us to write each and every time this type of big, what should I say, expression. Rather, once I have just specified this function, from here I can just do all of my jobs. x3 is equal to gx2. Are you okay with this idea? Anyone? Do you have any problem?
No, sir.
314. 314.
Yes, sir. No problem, sir. It's okay.
No.
Yes.
310. 310. So,
Yes, sir. Yes, sir.
any
Sir, আমার
problem?
মাইকে সমস্যা করতেছিল।
সমস্যা আছে কোনো?
স্যার ওই যে মাইকে স্যার একটু সমস্যা করতেছিল স্যার।
ওইটা সমস্যা না, তোমার সমস্যা আছে, আমি বুঝতে পারছি।
ও না, জি না স্যার।
এই তোমার নাম কি? মাহিন নাকি?
না স্যার, সাদমান স্যার।
Sadman.
Which
Okay.
one?
Actually, I am not seeing the screen. That's why I cannot see your names. Okay, no problem. So you can see that in the second step, when I am going to find, at first what I need to do, I need to estimate one root. Okay. So first one is estimated. Suppose like this, x1 is equal to x0, any value. Okay. I'm going to estimate, and for the upcoming values, that means xi plus 1. What I need to do for upcoming one, what I need to do, I need to put gxi. Okay, are you okay, everyone, with the second step?
Yes, sir.
Yes, sir.
Then it's important to check whether this condition is being fulfilled or not. Why? Because if this condition is not fulfilled, then I will just what should I say, I will go for iteration one after another, but I'm not going to get my solution. If you have observed here, you can see here, okay, from this portion, you can see at first it was 1.6, then 1.66, then 1.5. That means that was decreasing, but at one stage that has increased, again decreased. That means it will simply increase, decrease, and ultimately it's not going to give me the solution. That means it's not going to merge. Ultimately, I'm not going to get the solution. That's why it's important to see whether the condition is being fulfilled or not. After this, as Tahsin was telling, that if I have any specific error mentioned, suppose here absolute relative approximate error is mentioned. Okay, suppose the error amount is 10 to the power minus 4. Okay, so this is the error amount It may be in percent or it may be in point, no problem, okay?
Yes.
So suppose here they have used percent, okay, that's why I'm using percent. So this is the error limit that I am going to consider. So for this scenario, when they have not specifically, so they have specifically mentioned regarding the error amount, then what I need to do, I need to check the error every time, as they have told absolute relative approximate error. That's why this equation will be used. You can see x, this is x new, this is x old, this is x new, okay? So from your first lab you are supposed to know all those things, okay? So after this, what I will do, I will simply
Sir,
check. Yes, please.
sir, is this 10 to the power 4? Is it going to be given all the time, or
Yeah, for
are
all that.
you going to be given this?
Okay, I'm telling.
Okay.
So here is not required, okay? So at this stage I am mentioning, suppose at any iteration, so each iteration, if it's iteration number 5, then x5 minus x4 divided by x5, okay? So here I am finding that one, okay? So from here, from this x new, okay, this is x new actually for this stage, okay? For n
Yes.
is equal, for I is equal to 4, for I is equal to 4, this is my x new, okay? So
Yes.
in the fifth step, what I will do, I will check this error, whether this error that I have found is less than my 10 to the power minus 4 or not. If this is not, okay, if this condition is not fulfilled, so if this condition is fulfilled, okay, suppose at my fourth, so at the value of I is equal to 4, this condition is fulfilled. Once this condition is fulfilled, then I will not go for any iteration. Rather, this x new, that means what's x new here? x5. This is my solution.
Yes.
But if this condition is not fulfilled, then what I will do, I will go for iteration again in this stage. That means I will find new x. What's new x? Now my new x will be then x6, isn't it?
Yes.
Then my I, because I was 4, then my new I will be 5, and new value of x will be x6. Again I will find the error, okay? Suppose here error will be found out. Then I will again check whether this error is within my tolerable range or not. If this is within my tolerable range, that is, if this is less than that one, this condition is fulfilled, then I will, as there was not solution, then my x6 is the solution, okay? But again, if I see that x6 is not fulfilling this condition, then what I need to do, I need to go to this stage again. Then I will find another x7, okay, another x. So my new x will be x7. I will find error. Here I will check this condition, if x7 is fulfilling this condition or not. If this condition, as that was not fulfilled, that's why x6 is not my solution. So if x7 fulfills this condition, then ultimately my x7 is the solution, okay? So as per Tahsin, my n is not fixed here. So it may take 1,000 times, it may take 2 times. So what my value of x4 error is, depending on that one, my iteration will go on.
Sir,
Okay.
I have a small question here, sir. May I interrupt you, sir? Sir,
Please.
in this case, sir, like when we are to iterate this, sir, right? It might take 1,000 or it might take 5. Sir, how will I make my program know this, sir? By the while loop, sir? This case?
In this case, yeah, you can use while loop.
Or, sir, is there any
Actually-
other way, sir? Like other than while loop, sir? Like other
Actually,
than what? Yes, sir.
other than what you can do, you can simply take for, suppose you can start from any, suppose if you take for loop, what you can do, just you can start from 1 and you can take a very big value, okay?
Yes, sir. This
Take a
is like
very big
very.
value.
Yes, sir. It is
But
very like.
you are not going to iterate for this time. Why? Because it will just kill your long time, okay? So
Yes,
what
sir.
you will do, within the loop, you will just give one condition. Whenever this condition is fulfilled, it will go out of the loop. Have you understood?
Okay, okay, sir. Okay, sir.
Anyone you can do, any idea, okay? Last year, actually in this lab, probably at the end, you are not going to get the solution. I don't know what. Okay, doesn't matter. You can try, okay? So are you clear with the scenario?
But sir, one question, Tyler, sir. You said that give a condition inside the loop so that when it is met, it will break, sir. But
Yeah,
sir,
it will break.
but in order to ensure that, sir, we have to give this big 1 to 1000 number of iteration, for example, sir. So isn't this a very inefficient code, sir? If I think it like that.
Can you please tell again?
Yes, sir. Yes, sir. It's like you said that after doing the iteration, we give a condition inside that will cause the loop to break, right, sir? But sir, if I use a for loop that goes on from 1 to 1000, sir.
If you want, what should I say, efficient method, okay, what you have to do? So why I have used this one? Can you tell why I have given this one? Actually, it's very easy. With the help of while loop, you will just check. You can just check less than or greater than anyone. You can check. Okay.
Yes, sir. Yes, sir.
With the help of anyone, you can do that. So if you want efficient calculation, then you have to code efficiently. So you are wanting to code say inefficiently, and you are desiring something efficient result. That's not right. On the other hand, if I use for loop for 100 times, I have told that all 1000 times. I am not going to iterate for 1000 times.
Oh, okay.
Once I will get my solution,
it will break.
Then I will just break this loop.
Yeah.
Okay, that doesn't mean that it will complete for 1000. Okay, so different ways are there, and within the lab, it was completed by your previous batch, by your seniors. Okay, and they have done, and I have seen that one. Probably from there you have got the idea. Okay, listen. Now, if this error is not mentioned, we can just specifically up to this, actually this two portion. Okay, let me okay, this one. Okay, so these two step, this few step is okay. So up to finding x new, okay, that's okay if my iteration number is mentioned. Okay, if it's told that n is equal to 5 or n is equal to 10, then it's not required to think of these things. Okay, whether my error is less than this or not. Then what I need to do, if I just use even this equation, this equation will just give us the value of error. Okay, that means it will give me the idea how much error is giving for each and every step. Okay, but this condition is not required for this scenario when my specific number of iteration is given. Are you okay with what I'm telling? Anyone, any problem?
No, sir. It is okay, sir. Yes, sir. If number of iteration is given, sir, then it is not needed.
Yeah, not needed. But in your example code that has been shown, just to show you that how much error you are getting. Okay, so 308. Okay till now?
Yes, sir.
Very good. So now another method is Newton-Raphson method. Okay, so my target is to complete this lab sheet, and all the elaborations are actually based on that lab sheet. Actually, the lab is being big, but if you just kindly give concentration, I think it will help. Very interesting course. Okay, I like this course.
Sir, I have a question, sir.
Please.
Sir, while calculating the error, sir, we need to know the true value. So we want to calculate the true error.
Listen, you have learned different methods, isn't it?
Yes, sir.
So in your first lab sheet, if you check your relative approximate error, then it's actually okay. Let me show you.
So it is the previous approximation, current approximation minus previous approximation.
Present approximation minus previous approximation. This is approximate error, and relative approximate error is actually this divided by present approximation. Okay, that means the present approximation. Are you okay?
Yes, sir.
Have you got your answer?
Yes, sir. So, but if we are asked to find out the true error, sir, from where we get the true value, sir?
Actually, that's why they have used approximate one, because you don't know till now. You haven't found that one, isn't it?
Yes, sir. Yes, sir. My question is
trying to find that one. If it were found out by me, then why I am coding like this, isn't it?
Yes, sir.
Okay, no problem. So everyone, please, you can ask any question, no matter how silly the question is, no matter how tough the question is. It's not like this that I will be able to answer all the questions. I know very little, okay? So if I don't know, I will try to know, and I will try to let you know later on. No problem, okay? So it's not like this that I will not be able to answer that, so you will not ask. It's not like this, okay? So now I am going to learn which method? Newton-Raphson method. Newton-Raphson method. So in this method, suppose any equation I want to solve. Suppose I am giving one specific equation, fx is equal to, suppose, x square minus 612. Okay. So at first, what I need to do, I want to solve this equation. This is a nonlinear equation. Okay. So from this fx, at the first stage, my work is to find the derivative of fx. That means dfx divided by dx. Okay. So what's that? Can anyone tell? This is 2x, isn't it? If I derive this one, if I take the derivation of
Yes,
this
sir.
one,
2x.
this
sir.
is my 2x,
Yes, sir.
isn't it?
Yes, sir.
Yes.
2x. That means my first job is to find my fx prime from fx. Are you okay, everyone?
Yes.
Yes.
Now let's make it as gx. Okay, as this is a function of x, this is a function of x. So let's consider this is gx. Okay. Now, in the first step, I have done that. In the second step, what I will do? I will just consider one initial value of x. Suppose x0 is the initial value of x. Okay. So let's take x0 is equal to 10. Okay. Are you okay with second step?
Yes, sir. 10.
So
Yes, sir. Hello, sir. Yes, sir. It's okay, sir. Hello, sir. It's okay. Yes, sir.
are you with me?
Yes,
So
sir.
is there any
Yes,
problem
sir.
in my connection?
So we are getting you though.
Sir, we can hear you, sir.
Can hear you, sir.
Okay, okay. Very good. So if there is any internet connection problem, so in the second step, I will find one initial value of x. Okay. Then what we will do in previous case, how I was going to find the next value, that is new value of x was found out by this one. Can you remember in the previous case I used to use this one? Can you remember for the fixed iteration method I was
sir.
using this equation to find my next new value, isn't it? But
Yes, sir.
in this case,
Yes,
to find the x new, that means x new, what I need to do, x new is equal to x old minus fx old divided old, that's actually old, divided by f prime x old. Okay, so this is going to be used by me. Okay, so if I just make it like this, xi plus 1 is the new value of x, xi is the old value of x. So this is actually gx, like gx. So with the help of this condition, we are going to find the upcoming value of x. Okay. Now x0 was found out by me. So how I am going to find x3, x1? I will simply put this equation here. Okay. So here x1. So if I put x1 here, then actually I is 0 here, isn't it?
Yes, sir.
That's why
Yes, sir.
x0, that's x1, x0 minus fx0 divided by f prime x0. So x0 is how much?
10.
Sir,
So 10,
x0 is, sir.
Is
how
10,
is
sir. 10, sir.
10. 10. And fx is, can you remember what is fx? Fx is actually this equation.
Yes, sir. X square minus 612.
Your
X
equation.
square is minus 612, isn't it? So x is actually 10, 10 square minus divided by which one?
Divided by 2x.
2x. 2x, x is actually 10 here. So I have put this value. So ultimately we have got 35.6. After first iteration, I have got this one. So during my second iteration, so now again, what's important to check? I need to check the difference between them. Oh.
Yes, sir.
Sir, how to actually predict the initial value?
Just wait. Let me see. Okay. How to predict initial value? Okay. So initial prediction may be any. Okay, because I don't know what my initial value is, but taking initial value near to the solution is important for Newton-Raphson method. This is one of the disadvantages of Newton-Raphson method. Have you got me? I don't know what my
Yes,
solution is. That's why totally arbitrarily I have to select one value of x. Okay. So you can see this is actually the solution will be root of x. Okay. So I have to select one value near to the solution. That's important. But you can see ultimately my solution is 24 and I have approximated 10. So there is a huge gap. Okay. But comparatively very big gap that may create some problem. Okay. So in your theory class, you are supposed to learn the advantages or disadvantages or the limitations of different methods. Okay, probably all of those things are learned by me, and you are supposed to know more than me because I am not going to the theory classes right now. So arbitrarily, for now, arbitrarily I am going to take 10. Okay. So now in the next step, when I am going to find now what I need to do to see whether my solution is merging or not, I will just check the difference between x0 and x1 is around 15.6. Okay, after first iteration. Now, during second iteration, what will be my I will be 2. Okay, so I is actually here I is equal to 0, here I is equal to 1. So value of I doesn't matter. Why? Because during your coding, you can start your iteration from I is equal to 10 to suppose 15. That means ultimately 5 or 6 iteration will be there, isn't it? So here it may be 0, you may start from 0, you may start from 1. Okay, so here actually in this example, so I is actually 0, that's why I plus 1 is equal to how much? 1. So here for this iteration I is equal to 1, that means I plus 1 is equal to how much? 2 is equal to xi, that means x1 minus fx1 divided by f prime x1. Okay, so now what's the value of x1? X1 is actually how much?
X1 is
35.6.
35.6, sir.
Okay, now fx1 I will just put the value of x1 and this is the equation. Okay, again f prime x, this equation, and I will just put the value of x1. Are you okay? So
Yes, sir.
now you can see after second iteration the difference has decreased. The difference is around 9. Okay, so again I will just go for another iteration. After that you can see that during the third iteration my difference is around 2. That means my error is completely decreasing. Okay, and after another iteration you can see my solution, the difference is very less. Okay, very less. So I am merging. So for I is equal to 4, x is equal to 5, my solution, you can see the difference is very less, very less. Okay, so you can see, so we can consider this as my solution, x5 as my solution. Okay, so in this way I can go for up to 100 iterations. Okay, so up to 100, so the solution that I am going to get, that's actually more and more precise. So are you okay with the method that I have told, the example? Are you facing any problem with the example? Just
Yes.
check. fx will be given. You will be told to solve this one. Then from at first, what I need to do? First job is to find the derivative of fx. So the derivative of xs has been found out. In the second step, what I need to do? I need to get any initial value, and after that I will go for iteration to define new values of x. So which equation will help me to find the new equation? This equation will give me the new values of x, define new values of x, and I will iterate in this way. I will iterate up to one specific number or up to a unspecific number of iterations when the error is specified. Are you okay with
So, sir, the initial value, we will take what we want, or it will be given to us. It will be a given.
Yeah, obviously in your question, okay, if your teacher told you that you can consider initial value like this, then it's okay, from there you will start. But if it's not told, then you can assume any. But I have told that one disadvantage of Newton-Raphson method is it should have one initial value. Just wait. Okay. So it should be near to the solution. But actually, if you just observe this example, then you will be able to see your solution is something 24.73, but your approximation is 10. So difference is completely big. Okay. So this is arbitrarily for now. But in the example, in the question, it may be told that take initial value something like this. Then it would be easy for the teacher to justify whether you are right or not, because everyone will give the same solution and I will just check. But if everyone gives different initial value, then for the teacher it may be tough to verify. Okay, so no problem.
So,
Sir, one small question, sir.
This.
Yes, sir. So, sir, in this case, we are also taking like 100 iterations, sir. So, like, is there, sir, any like generalized number of iterations that is considered so that we can say that this is the good number of iterations that if I run in my program, my accuracy will be met in most cases? Erokom ki kono ache, sir?
Okay.
It's like
Now,
100 or 1000
I was
or
telling
can
some
you say?
disadvantage of Newton-Raphson method. Okay. Now I am telling one advantage of Newton-Raphson method. Okay. So obviously, in many of the cases, so among the disadvantages, another disadvantage is Newton-Raphson method may or may not merge or converge. Okay. So, but if it converges, then the advantage is it takes very less number of iterations. Okay, less number of iterations. Suppose 5 or 10, that will give you very good result. Okay, in maximum of the cases it gives. If this converges, if one disadvantage is it may or may not converge. One advantage is if it converges, then it takes comparatively very less number of iterations. Okay, so this is for which method? Newton-Raphson method. Okay, so whenever you are coding for Newton-Raphson method, you can think that n is equal to or iteration number is 5. Okay, but it depends on the method. Suppose if you use another method, suppose fixed iteration method, fixed, what was that?
Iteration. Yes.
Fixed point
Fixed
iteration
point.
method. Okay,
Yes.
so for that it may take comparatively big number of iterations, comparatively large number of iterations. Suppose n is equal to 20 may give completely better result. Okay, so this is from your knowledge, but okay, from your advantage, disadvantage, you can just start in this way. Okay, so whenever you are coding Newton-Raphson, then you will start with this for
For fixed point, we will use
fixed
this.
point, you can take 20. But suppose if I don't have any idea, then what can I do? I can just write n is equal to 5 for any method. Okay, for different methods, I can write 5. Then if I see the error is completely very big, 5%, then I can take n is equal to 10. If I see the error is 1%, then I can go for n is equal to 15. Okay.
Okay.
This is the answer for your question when your EA is not specifically mentioned. Rather, you are just arbitrarily iterating. Okay. But whenever your EA is mentioned, then you can never consider this one. Okay. At that time, obviously, you have to go for that much time, as much time you need to do your iteration for getting this much accuracy. Okay.
Answer that will always be like, sir, within the range of 0 to 100 iterations, sir. Can we say this confidently?
No, how can I tell?
But
It may take more.
yes, but sir, if my iteration runs for 100 and my accuracy level is not met, sir, so how do we tackle that problem, sir?
Actually, listen.
Yes, sir.
So whenever you will do, you have to check the code, okay?
Yes.
If you see that one method is taking 1000 iterations,
Yes.
then will you go for that iteration? Many other iteration methods are there, okay? So why we are learning different methods?
Okay.
If people like me, if I think that I will just learn one method, if it take 100,000 times, I will just manipulate this method to just solve this one. No, why? Different methods are there. So
Okay, sir.
and
Yes, I understand, sir.
also initial value is also important, okay? Not only the equation, not only the method, initial value is also important. If your initial value is so much deviated from your actual value, then the iteration number may take completely more time. At that time, you can just you can just decrease or increase the value of
Yes, sir.
initial approximation. That may take comparatively less number of iterations. So different other ways are there. You can think of like, no problem.
Yes, sir.
So what my target is, so all these things are not actually my target. My target is to make you understand the left sheet. So anyone, do you have any problem with this portion? Anyone?
No, sir.
Okay, let's go to this left sheet. Then I will just show you the code. Then I'm done. Okay, now, so this is the equation which I need to solve, okay? So for this, first of all, what I need to do, I need to find the derivative. Can you remember derivative? Then
Yes, sir.
what I need to do, I need to find I need to consider any initial value, suppose x0, where xi is equal to x0 for the initial one, okay? I need to approximate one initial value. For the upcoming values, what I need to do, I need to use this equation to find the upcoming values. After this, what I need to do, I need to find the error, because every time I am going to find one new value of x, then I have to see how much error is there, okay? So then from this error in the next step, what I need to do, I need to simply check whether this error is less than my tolerable range or not, okay? 10 to the power suppose -3. If this is within the tolerable range, then the x new will be my solution. If this is not fulfilling the condition, this condition, then I will go to step number 2, and again I will find another x new I plus 1, okay? Suppose x2, okay? So again I will check whether for x2 this is condition is fulfilling or not. If this condition is fulfilling, then x2 is my solution. If this condition is not fulfilled, then it will go for another iteration and it will find another value of x3, and then it will check how much error there is, okay? And it will check this condition is fulfilled or not. If this condition is fulfilled, then x3 is the solution. If not fulfilled, it will go for again iteration, it will find x4. Again it will find the error, and if the error is within the tolerable limit, then x4 is the solution. Are you okay with the theory?
Yes, sir.
So,
Okay, sir.
Yes, please.
so is it necessary to find the error in every iteration? Like after every iteration, is it necessary to find the error?
So if in your problem error is mentioned, okay?
Yeah.
Suppose your problem is something like this. Solve this equation, fx is equal to e to the power minus x minus x. Solve this equation so that the solution is like this, that its error, relative approximate error, is less than 10 to the power minus 3. If this type of equation, this type of condition is there, then you have to find the error in each and every iteration.
Okay, sir. Okay.
But if the problem is something like this, is told in the problem that fx is equal to e to the power minus x minus x. Find the solution of this equation. What is the solution of this equation? Using iteration, using 10 times of iteration. Okay. So if this type of things is there, then it's not required for us to think of the error at all. I will just iterate for 10 times and I will find the value of x. So at that time, if I am curious to see what my error is for each and every step, then within the iteration, within the loop, I can put this equation. On the other hand, if I am interested to see what's the error for my solution, ultimate solution after 10th iteration, then after 10 iterations, oh, then it will not work. Then I can find the how should I say, another type of error. Okay, relative true error or true error can be found out. Okay, but if I want to, in this problem also, if I want to see the relative approximate error, then obviously within the loop I have to put this equation. Otherwise, the previous steps for the 10th x10 I am going to find, but x9 error is not in my hand.
Yes, sir.
Okay, x9 value is there, no problem. So based on your question, you can do whatever you are in need. Okay, so let's go to the problem. Okay, coding. Now, in your problem, actually, n is equal to 5 times that has already specified. That's why this equation, this equation with the help, this equation has been used to find the value of error every time. Okay, but this condition has not been used because this condition is not required as we are going for specific number of iterations. Inan, are you there? Inan? Everyone?
Sir, we are here, sir. Yes, sir.
Yes, sir.
Kindly write your student ID again in the comment section. It will be counted as your present attendance. Okay. This is 10:10. Write your student ID in the comment section.
So where is the comment section? Please.
Yes, chat.
Oh, okay. So,
So everyone write your student ID in the chat section. It will be recorded and I will just check whether you are present throughout the class or not. Or you are enjoying. You are good. Your batch is good. I like your batch. I don't know
Sir.
regarding others' opinion. But
Sir, I
happy.
joined late. Sir, I joined late, so I missed the attendance.
Okay, you can write right now. Okay.
Yes, sir.
What's your
302.
ID?
Yes, sir.
302.
302.
Okay, I will consider inshallah. So are you with me?
As well, sir. Yes, sir. Yes, sir. We are with you,
302.
sir.
Are you updated with me? 302. Are you getting me?
Yes, sir.
Yes.
Okay, very good. So I am done almost. Okay, the code looks very big. Okay, you can see 1.5 pages are there, but truly speaking, the code is very small. All the unnecessary things are mentioned here. Okay, all the unnecessary things are there. Okay, now let's see. So this is the code. So all of you know all the basic things, but if you want, I can tell everything. I don't have any problem to specifically mention everything. It may be you who may get tired of it. So at first, let's see. So this very big code, actually the whole code is unnecessary. Unnecessary means main important thing is actually this red color. You can see this red color, 6 lines. Okay, 6 to 10 lines. Actually, that's the main code. 6 to 10 lines. That's the main code, and the main codes things are also very easy. Okay, so you can see this portion and this portion. That's the main thing. Okay, others are actually figures. Then y max, y minimum. Okay, all those things. Then initialization and declaration. So these are very simple things. Okay, I'm going to going through everything. Okay, so what's the work of CLC? It will clear the command window, isn't it? You know very well. But I'm telling you, clear all. It will just clear the workspace. Then close all. It will close all the figures. Then what's the job of format long? Anyone know? Anyone? Do you know? Have you used format long?
Yes, sir. I think all the values will now be given in the long format, sir. Like
Long format
EX will be given to a greater number of decimal places.
Yes, very good. So actually, MATLAB version is important. Okay, MATLAB version is important. So I'm using 15A, 18 is there, 19 is there, okay, 16 is there, 20 is there. So in some of the cases, format long may not be required for you. Okay, but you can use. Okay, suppose as Tasin told 3.1416. Okay, suppose one specific number of decimal after decimal point, one specific number of digits has been considered. But if I use format long, then it will give 3.1416, like up to probably 15 digits. Okay, so why this is important? Can anyone tell? In this code, in maximum of the codes, it's not important, but in this code, it's important. Why? Can anyone tell?
Because we are trying to determine the
Yeah.
real value, sir.
Real value is more importantly, our goal is to just find one error. Okay, actually,
Errors,
although
exactly.
we are not depending on this one, but these errors is actually, it may be of this range. Okay, that means if I don't consider after decimal point up to 10 to the power minus 10, after decimal point 10 points are not considered, then actually I am not going to get those solutions properly. Okay, that's why. And obviously, even if I don't do so, whenever I will go for 10 iterations, okay, or 5 iterations, it may happen my value of AX is so much precise that after 10 points, suppose 20 points, something, 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 after 10 digits, okay, you can get difference. Okay, suppose third iteration or fourth iteration, or X7 and X8, they are so close to each other that format long is important. Everyone, are you okay with this up to now?
Yes, sir. Yes, sir.
Okay,
Yes, sir.
okay, very good. Now I am going for format long. Okay, format long, you are done. Now Sims X. Sims X actually, have you used Sims X till now? Anyone?
Yes, sir. But we forgot, sir, what it was.
Okay, no problem. I will tell everything, no problem.
Okay.
I don't even expect that you will be able to answer, because I have used this one last year, but
Yes,
probably before my preparation, if someone asked me, it would be tough for me to answer
yes, sir.
because my memory is not that much good. Okay, so now let's see. Simsex is actually, it will create symbolic variable and function. Okay, Simsex, it will create symbolic variable or functions will be created. Why symbolic variable or function is created? Because if make this x as a variable, then I can find one fx. I can directly write fx is equal to something like this. If I don't use like this, if I don't use, just wait. These are initialization and declaration. Okay. So if I don't do so, what I can do another way, x is equal to suppose 0.1. If I just specifically mention if x is equal to 0.1, then whenever I am going to find fx, at that time it will be one specific value. Okay, it will be one specific value, but I don't want that. I want my x to be one variable so that I can differentiate this one, and so that I can utilize both fx and gx. That means derivative of fx. Derivative of fx. That's why Simx has been used. It will give us symbolic variable or symbolic function. Okay, and for more elaborative answer, you can just simply search in your MATLAB. That will give you very nice elaboration.
Okay.
So for now, it's okay to understand up to this portion. Okay. Now after this, one of the very important job for us is to find fx. And what's my fx for this equation? Fx is equal to e to the power minus x, and I have written this one. Fx is equal to e to the power minus x. Up to this portion, anyone? Do you have any problem?
No, sir.
No, sir. Now, suppose any initial value, I want to mention any initial value. Okay. So any initial value was x0. So that's why I have to mention x0. So for this I am mentioning x0 is equal to 0. Okay, this is important. Another important thing for this code is a is equal to 5. This is the number of this is the number of iterations. Okay.
Yes, sir.
Another important thing for this code is I have to find g. What's g? G is the derivation of fx. So for this version of MATLAB, d divisible f, it will give the derivation of function x. Okay. So you can see our first step is done. What was my first step? To find fx. I have found that one. I have declared fx. I have found out f prime x. So in this case, very simple thing. Nothing is there. Nothing logical is there. Okay. Are you okay with this till now?
Yes, sir.
Yes, sir.
Okay. Now, some unnecessary things has been done. Some unnecessary things have been done in your code. Okay. Just to make you understand. Okay. What they have done in this code, actually, the code's main purpose is to find one x new. That x new will give a perfect solution. My target is this one. Okay. So in this code, actually, what they are doing, they are just making one graph. Okay, just to make you visualize. Okay, suppose one graph something like this. Okay, it will be from -1 to 1. Okay, x range will be from -1 to 1, and y range will be some specific range. Okay, and within this there will be one x-axis, there will be one y-axis. Okay, then one curve will be drawn. Suppose this curve is something like this. I don't know what curve is. The curve will look something like this. Okay, this means this is fx. Okay, so this point is actually my solution, isn't it? This point here, x is equal to 0, fx is equal to 0, isn't it? At this point.
Yes, sir.
Are you getting me?
Yes, sir. Yes, sir.
What they are doing in this code, one unnecessary thing that will make you visualize in a better way. They are just making one line, green line, which will be representing x new, and they are going to make another line that will be my x old or x previous. Okay, x present and x previous, two lines will be there. So in one step, suppose in one step it will be shown. Okay, in another step the same thing will be shown, but here what will happen? Can anyone guess? In the second iteration, they will be comparatively close to each other. They will be merging. In the third step, they will be comparatively near to each other more. Okay. In fourth step, you will be able to see one is just above another. Okay. So this line, other curves will be there. Okay. Within that curve, you will be able to see this line is changing. Okay. Just to show you this visualization that my x new and x previous is merging towards each other with each and every iteration, just to make you visualize this thing, they are doing all these things. Okay.
Okay,
sir. Now let's go for the code again. So these two lines I haven't mentioned. Why? Now let's see. They want to show me one curve where the lower range of x will be -1. They have done -1, that's why. Are you okay? Upper range of x is 1. They want to make us visualize. That's why they have taken upper range of y is equal to 1. So x is equal to 1. So they are not actually that much important to find the solution. Rather, they are important for us to visualize how my output is coming. Now, so this one and this one. Are you okay with whole page? Is there anyone? Any problem in this page? I'm done almost.
This is just for the visualization purpose, sir. This
for the visualization
and UX. Yes, sir.
These are important things.
Okay.
Okay. Now,
yes.
Let's go to the next page. So here, for these x and y, here I have just mentioned the limit of x. Okay, -1 to 1. So for this, the corresponding value of y, actually y, this limit, not the limit, rather the limit of function of x, that's actually being found out. Okay. What's actually we are finding here what? We have found x minimum, we have estimated x minimum and x maximum. Okay. Now I want to find for this curve. For this curve, what's this curve? This curve is fx. Now I want to find the y value of this curve. Suppose fx is equal to y. So what's the maximum value of y and what's the minimum value of y? What's the maximum value of y? What's the minimum value of y? I want to find these two things. Okay, and for this I am doing this thing. How I am going to do? Suppose upper limit of
Sir,
y.
why do we need those two values, y maximum and y minimum?
Yes, just to draw the curve, nothing else. Have you understood? With the help of these two, we don't have any logical thing in the code. I have shown you different logics. Okay, so not in the algorithm. I have shown the algorithm, isn't it? So within the algorithm, in the logic, they are not required. They are required for the figure. Okay. So at the end, whenever I am going to show you the full figure, then you will get all the answers. Okay. Why upper limit? Why lower limit? But here also I have just told you that ultimately my curve will be something like this, and they are going to specifically mention like this. Okay. You can see they will draw a curve like this, and up to this one they will just make one line. Okay, green line suppose, and green line's lower limit and upper limit will be actually the upper limit and y limit of lower limit of this function fx. Okay, that's why we are finding.
Okay, sir.
With time we will be more clear, inshallah. Are you okay with this
Yes,
till now?
yes, sir. Yes,
Okay. Now, upper limit of y and lower limit of y. So we are considering, because from this point to this point, many points are there. Okay. So let's consider for this point. You can see lower limit of x. That means -1 has been considered. Okay. Both of the cases -1 is considered. So for these values, I have considered upper limit and lower limit. But actually, for this value, this is not the upper limit, or this may not be the upper limit, or this may not be the lower limit. For any other point, I may get for any other value of fx corresponding to different x from -1 to 1, I can get another fx, which fx may be greater than this one maybe or may not be, isn't it? That's why what I need to do, I need to find the value of fx for all other values of x inside this. Okay, so let's take 10 points. Okay, for I is equal to lower limit of x, that means -1, to upper limit of x, that means +1, and this range is divided by 2, is divided by actually how much? 10.
sir.
That means
Sir,
0.2.
10 division.
Okay, I am just taking 10 arbitrary points here, 10 arbitrary points here. Okay, 10 arbitrary x here, and for this arbitrary 10x values, I am going to find 10 fx. Okay, 10 fx will be found, and for each and every time I have to check this fx is greater than my upper y or not. Okay, if in any fi my upper limit is greater than this approximated one, then actually that's my upper value of y, that means y max. Okay, on the other hand, I will check for every iteration if this fi is less than this initial lower value or not. If at any time this is lower than this range, then that's actually my lower limit of y. So whenever I will be out of this range, then I will get these 2 points. Then I will get these 2 points actually. These 2 points. Okay. This will be my actually uy range. Okay, that means upper y. And this will be my lower y range. Okay. So just to find the upper and lower points, they have done all these things. These 2 points. These 2 points. Okay. This upper limit and lower limit, to find these two, they have done all these things. Are you okay with this till now?
Yes.
Anyone? Do you have any problem?
So, sir, this is just it to converge to the point, sir. It's like we are converging to that y value of the
Yes. Yes.
of the solution point.
Yes. One question may be like this. So I am taking 2 points initially. even though I don't know where the point is going to merge, okay? So I will take some initial value of x like this, x3 to x4, okay? So within this range, my solution is not available, okay? So this curve, will this curve work? Will this curve make visual? Will this curve help us to visualize?
It will
It will
not.
not help. So my ultimate target is not this -1 to 1 things. Okay, but this is given just for you to visualize how they are merging. Are you okay? Okay.
Yes, sir. Yes, sir. Yes.
Later on, whenever I'll show you. So all the unnecessary things. Now, another thing, figure 1 has been mentioned. Okay, so before going to the main part, before going to the iteration, they have just drawn one figure where they have shown all the unnecessary things that will help us to visualize. So let's see what is there within the figure. It will not take more time, okay, for me. Just try to concentrate. I know it's very tough to concentrate for a long time, but actually nothing to do, okay? But if you just take a bit pain, it will be helpful. Now, that portion, okay? That portion I have just taken here so that I can just show you nicely, okay? So x previous is equal to x initial. So x previous is actually needed for my loop, okay? And x initial that has been already mentioned by me, okay? What's that? Can you remember? That was actually 0. We have considered. Can you remember? X initial was considered 0. So we are, yeah. So initial at the very beginning, x previous will be actually x previous will be how much? At the very beginning, x previous will be x0. But for all the other steps, my x previous will be different. X1 for second iteration, x1 for third iteration, x2. Are you okay?
Yes,
So for the very beginning, my x previous will be x initial. That means 0. That has been written here. Okay. Now, figure 1. Figure 1, what we will do? It will just make one specific figure. Okay. And it will be written there, figure 1. Then f plot will plot a function for variable range from lower range to upper range. Okay. So with the help of this line, we are simply plotting this fx, function of x. Okay. From lower limit of x, that means from here to upper limit of x here. Okay. So from here to here, my fx is drawn. So this is the line. This is the line. So are you okay with this line?
Yes.
Anyone? Any problem?
No, sir.
Okay, very good. Now, hold on. What will this hold on do? Hold on, just it will just hold this figure to adjust to accommodate more curves. Okay. So now I want to draw, because this curve has been drawn. I want to draw some other curves. So this plot, okay. This plot will just plot x previous. What's x previous here? 0, isn't it?
Yes, sir.
0, 0, 0. Upper range of y. Upper range of y has been found out, okay, by my equation. That's the upper range of y, okay. That has been found out by the previous section, isn't it?
Yes, sir.
And upper range of y has been found out by us in the previous section, isn't it?
Yes, yes, sir.
Okay. And lower range was also found out by us. Suppose this some place of where. So within this range of y, we are going to plot 0, 0. But you can see the range of y is varying from this much to this much, but x value is always 0. So ultimately, green line is the line which we are plotting with the help of this one. You can see G is written, okay. G is the green. So this is the line. So this has been plotted here, okay. And with the help of line width, they have written 2. That means line width will be 2. Okay.
Sir, just one small question, sir. Sir, if you don't mind, sir, could you scroll up, sir, a little bit, sir? Just a little bit.
Yes, please.
Yes, sir. Sir, in there we ran that for loop, right, sir? in order to find the f range, f upper range and f lower range, right, sir? So, sir, how is that? That is not going to benefit this graph, sir. That is not related to this graph.
Okay, listen.
Yes, sir.
Listen. What you are telling, any range is not required, but they have specifically mentioned for just to visualize us. Okay, I have told that they are going to draw some line here. Okay, that line will represent x new. Later on, I will be showing you. Okay, that line's upper limit and lower limit will be used by this upper range and lower range. Are you okay?
Okay, sir. Yes, sir. Okay, sir. Okay, sir.
And also here is used. Here is used. Here is not drawn from this point to this point. Rather, it has been drawn from the upper limit of y to lower limit of y. It's used here. Have you found the use of this range?
Okay, sir. That part converge the both f upper and f lower to one single value, that fi, which is used here. But
actually, this point as this point, the y value, this point has been used here. Okay, upper limit has been used here. Lower limit one value. Suppose upper limit is 3.7. Okay, we have found out from the loop, and lower limit is suppose minus 0.6. Okay, we have found out from the previous section. Okay, so why are they using? This is the question. They are using here. You can see in this line, they have used the upper limit and lower limit like this, and they have drawn one line. Okay.
Okay, sir. Okay, sir.
So this green line is actually my x previous line. Can anyone tell? This is the first x previous, because my x previous line, you can see x previous line has been drawn here.
Yes, sir.
So
Yes, sir.
with the only this is actually 1 point. X previous is 1 point, but just to make you visualize, this point has been extended to one line so that you can see how they are merging. Are you okay with this line till now? Anyone? Any problem?
No problem.
Very good. Now let's go for the next line. Okay, next go for the next line. So here, x large to y large, x large to y large. So are you feeling boring?
No, sir. No, sir. We understood this. This was interesting, sir. Meaningless but interesting.
So listen, meaningless is meaningless for if I want to find only
the answer. Yes, sir.
But if I want to make something visualization like this, I need all those things. Also, whenever you are learning one thing, you can just use this thing for many other different purposes. Okay.
Absolutely.
So
sir,
probably in your upcoming classes, you are not going to see some curve like this. But
no, sir.
For all the solutions of upcoming lectures, you can use this type of coding to make some lame person visualize how you are getting the solution. Okay. So learning is helpful. Okay. So now in this line, you can see lower range to upper range of x. Lower range of x is -1, upper range of x is 1. Okay. From here to here, we are drawing this curve, and you can see in this case, my y value is 0. That means this line is being drawn here, and you can see this is k. K means black, and line width here is 1. Okay. So actually, this line, this black line has been drawn here. Okay.
Yes, sir.
After this, hold off means we are done with this figure. So figure 1 is complete with these 3 curves. So anyone, do you have any problem with this section?
No
I hope
problem.
not. Very good. So I have told that this explanation is not my target. What my target is? What's my target? My target is to explain this lab sheet. So I am done. So anyone up to this, anyone, do you have any problem? Very simple thing.
No problem, sir.
Now let's go to the last part and the main part. Okay. Now in this part, as I have told that we have specific number of iterations. That this number of iterations I am going to iterate. Okay. So n was specifically mentioned as 5, isn't it?
Yes, sir.
So now let's go for iteration I is equal to 1 with the interval of 1 up to 5. Okay. Now figure I plus 1. Figure I plus 1, what it will do? It will just give some figure where first figure will, whenever it will come to this loop, first figure will be figure number how much? Can anyone tell? First figure will be figure number
1, sir.
2.
Oh, sorry, my bad, sir.
I plus 1 and first I is 1. First I is 1. 1 plus
Yes,
1,
sir,
figure
yes.
number 2. So in the
Okay,
second
okay.
iteration, first iteration, figure number 1. During second iteration, it will give figure number
3, sir.
3. Third
Yes.
iteration, figure number
4, sir. Yes, sir.
4. Fourth iteration, figure number 5. Fifth iteration, figure number 6 will be given.
6, sir. Yes, sir.
Okay, so we are going to get 6 figures where we will be just visualizing that these two lines, that means x previous and x new, they are coming closer to each other. That's why they have done all those things. Are you okay, everyone?
Yes, sir.
Very good. Now, and the main part is easiest part. Okay, so already I know which equation will give, because one equation is very important for us to find the upcoming new values, isn't it? So for by Newton-Raphson method, what was that equation? Xi plus 1 is equal to xi minus fxi divided by fxi prime, isn't it? And
Yes.
fxi was how much? Gx. Can you remember? In the
Yes,
first
sir. The difference.
I have done that
Yes.
equation. I plus 1 is actually x new. X new is equal to x previous. X previous. X new is equal to x previous minus fxi or fx previous divided by gx previous, means f prime xi. Okay, are you okay with this line?
Yes, sir.
Yes, sir.
So after this, the next line is actually one unnecessary line, but it will just give me one value which I can, with the help of which I can check how much error I have with the solution that I have obtained. Okay, so that line is this one. You can see that equation has been written. Okay, which equation? Can anyone remember? The equation of
Sir, the
relative approximate error.
yeah, yes, sir.
Yes,
Relative.
that's
Yes.
actually x new minus x old divided by x new into 100. Okay, you can see absolute, there should be one absolute x new minus x previous divided by x new into 100. So EA, every time we are finding EA. Okay,
Yes, sir.
now let's go for this figure portion. That means figure 2, 3, 4, 5, 6 will be drawn here. Now let's explain this one. I am done. Okay, if you are bored, just forgive me and give me just a bit time. Okay, I am done.
Yes, sir.
So writings are very small, but you will be able to understand. Okay. So you can see, I told that this is the main portion, and already I have described this line, this line, this line, this line, isn't it? Now let's go
Yes,
to
sir.
this line. Now let's go to this line. Okay. So in this line, we are writing subplot 2, 1, 2. So you know this thing very well. 2 is the row number, 1 is the column number, and this is the number where we are working. Okay. So 2 rows. You can see this is the first row, this is the second row. First row, second row. Okay. And there is only one column. So you can see very well there is only one column. Okay. In this figure. Then 2. That means the portion where we are working, this is 2. That means in this portion right now we are working. In this subplot, we are plotting in this portion. Are you okay with this?
Yes, sir.
Now, at first, like previous, we are going to plot function from lower range of x to upper range of x. So this blue color has been drawn by this line. Anyone, do you have any problem with this line? I have
No,
already
sir.
shown it. Plot. Now,
Yes,
hold
sir.
on. Hold on, we'll just wait. Hold on, we'll just hold this curve to accommodate more curves. Okay.
Yes, sir.
Now we are going to plot which line? Can you remember? I have shown green line. This line, x previous, for the first time 0, 0, x previous, upper limit of y to lower limit of y, upper limit of y to lower limit of y. We are drawing one curve. That curve is going to represent x previous. Okay. So
Yes.
in the previous curve, in the figure 1, it was on 0, 0. It was on 0. But here it will not be in 0 every time. Rather, it will vary with the value of x previous. because every time with iteration we are going to update x previous. When the x previous will be updated, this line will be
Sir,
shifted.
one small question, sir.
Okay.
So in which part of the code are we updating the previous value?
At the last.
Oh, okay.
Oh, okay. Thank you for your question. Because I have already mentioned that the main code is this portion and
Yes,
this
sir.
portion.
Yes, sir.
Okay. So here you can see x previous. That means x I is equal to x I plus 1.
Yes, sir.
So I am updating x previous.
Okay, sir.
Okay.
Okay.
So again, I will go. Very good.
Thank you, sir.
Now, so I am done with this line. Now in this line again, I am plotting another line. This line I am going to plot. Okay.
Yes,
So
sir.
x new, comma x new. So x new is the new value of x. That means this is a fixed value. Okay.
Yes, sir.
So fixed x value. This is a fixed x value. So x new. So this is actually a fixed point. This is a fixed point which is representing by x new. Now upper range of y to lower range of y means I am drawing from here to here. Okay, and this is C means cyan in color. Cyan color is actually in between green and blue. Okay, and the line width is 2. So this cyan line is actually representing my x new. Are you okay with this?
Yes, sir.
So this line is done. Now plot this upper range of y. So this line, black line has been drawn. Okay, you have already seen. With the help of this one, from lower range of x, from here to here, one line has been drawn at 0. That means this line has been drawn here. Are you okay, everyone, with this?
Yes, sir.
Yes, sir.
So now we are going for the second subplot. Okay. So in the second subplot, we can see subplot 2. This is row number. Row number is 2. 2 rows are there. 1, 2. This is column. 1 column is there. This is the portion where we are working. We are working with 1 right now. Okay. That means in this portion we are going to work. Okay. Now we are going to write some text here. Okay. So you can see text is the command with the help of which we can write all these things. Okay. So text 0, 1. So suppose if this is the place where we are going to write, then 0, 0 is this location and 1, 1 is this location, and 0, 1 is this location and 1, 0 is this location. Okay. So now 0, 1, what's the significance of this 0, 1? It will just signify where I am going to put my text. Okay. So you can see 0, 1 is which location? This location 0, 1. Isn't it?
Yes, sir.
Yes, sir.
So in this location, I am going to write iteration with the help of sprintf. Okay. So you can see sprintf1 is written and it's a variable. That means with the change of iteration, the number will be changing. Okay. So in this
Yes,
place, with the help of this text, this line is written. Okay. Now with the help of this text, you can see 0.1, 0.8. X is equal to 0.1 means this one, and 0.8, suppose 0.1 is this one, and 0.8 is somewhere like this. Okay. So this is 0.1, 0.8, and at this position, this thing is written. This thing is written. Okay. Now in the next line, 0.4. 0 means this one, and 4 means 0.4 means this location. Okay. So at this point, some text is written. This text is written. Okay. So this is written here. So in the next place, you can see 0.1, 0.2, something is written. So 0.1 means suppose this point, and 0.2 is this one. Okay. 0.2. So this is actually 0.1 and 0.2. So in this location, another line is written. Okay. Something is written. So all these things are written after this x is off. So where this x is off is, this is within this subplot. That means in this subplot, there will be no x's. You can see there is no x's there. So no x's are there. Okay. After this hold off, why this hold off is important? Can anyone tell?
Yes, so that all the values are held and one does not remove the other.
All the figures, that means all the curves are within this figure. Okay. That means whenever I am going to deal with figure number 2, at that time, all these curves are within this portion. If I don't give this hold off, what will happen? Do you know?
Sir, it will
Next
go away.
one, all the things, all the curves will be merged. But hold off means figure 2 is done. Let's go for figure 3. Okay. So in figure 3, I will draw all these things again, and after that I will go for hold off. That means figure 3 is done. Let's go for figure 4. So everyone, are you okay with the code?
Yes, sir.
Anyone, do you have any problem? So again, this is not my target, okay? This is explanation. What my target is? My target is to make you understand this thing, okay? I hope you have understood everything, okay? Now, let's see the code. So, the code that is there, okay? So, same thing has been written here, okay? I haven't changed anything, okay? I have just copied and pasted, okay? So, whenever you are going to copy and paste, just remember one thing. Sometimes it may happen that your comment has gone to the next line, okay? So for that you have to just go to you have to correctify, okay? You have to correct that one, okay? You have to rectify that one.
Okay.
So other than this, I haven't changed anything in this code. So if I run this code, so you can see it's busy, it's working, okay? And I am using a very good computer. Alhamdulillah, I like this computer. From my undergrad, I am using this one.
Yes,
So
sir.
with age, it's a bit slow, okay? So let's wait. So my computer is faster than I think. So you can see, actually figure 6 has come here, okay? Figure 5 is there during 4th iteration, okay? So you can see during 6th iteration, okay? 5th iteration, figure 6 has come, okay? So all the figures has come just one above another, okay? So let's remove all these things, okay? Because there is no gap, that's why everything is coming together. So what I can do, I can just simply you can see I have given one pause, okay? Pause of 0.5 second. So in between the loops, there will be a pause of 0.5 seconds, so that I can understand that my X new and X old is merging, okay? Also after figure 1, let's give a pause so that I can see the figure 1 also. Okay, we have drawn figure 1 here. Hold on. So let's give a pause of 0.5 second, okay? Now let's run the code. Okay? So I'm done. Just I will show you. So you can see figure 1 is there, figure 1, and there only we have drawn all these things that has been shown to you right before. So figure 2 in the loop, iteration number 1, X new is this, error is this. You can see the green one is X new, right one is X previous and X new. Figure number 4, iteration number 3, you can see they have merged. Okay. You can see in iteration number 3 they have merged. So how first they are in iteration number 5 they have merged, but you can see error is comparatively less.
Okay.
In 5th iteration, you can see in 4th iteration it was 10 to the power minus 4, and in 5th iteration it's 10 to the power minus 13.
Sir, how are you moving the slides, sir? One after the another, the figures?
I'm not moving. Actually, automatically.
Okay.
There, and within the iteration, I have given one pause right now. Due to the pause, the next figure is coming after 0.5 second. Okay, that's why you have visualized like this. So sorry for this long time. Okay, 2 hours I have taken almost. Sorry for that. But those who are attentive, I hope they have learned it. At least a few things. Okay. Oh, now at the end, just last 2 minutes. Just allow me last 2 minutes. Okay. Okay. Now, suppose here Newton-Raphson method is this one, okay, and fixed point iteration method is this one. So in a Newton-Raphson method, fx is the main thing, okay. From there, I will just differentiate and I will find all those things. And in the fixed point iteration, finding x is equal to, just how should I say, finding x is equal to gx was important. Can you remember?
Yes, sir.
Okay. Now,
Yeah.
here for the same thing, for a, suppose the solution for this equation is something like this. Okay. So to find this one, what they have done, Newton-Raphson method. They have used, suppose, 4 iterations. Okay. Actually, there are 5 iterations because I is from 0 to 4. Actually, 5 iterations are there, isn't it? 1, 2, 3, 4, 5. X0 is also there. Okay, no, not a problem. Okay, so you can see 4 or 5 iterations are there, and for that I have got error of almost 10 to the power minus 8. On the other hand, here I have done for 10 to 11 iterations. For that, can you see till now there is 1.11 error percent error. So if I want to go to this limit, then Tasin, people like Tasin, probably he will just try to go with this one, and after 1,000 times he will try to just modify. How can I make this fixed point iteration so much efficient that it will just do like this? Only 3 to 4 iterations will go on. So different methods are there for this, okay? And also in your last section, one of your classmates, probably Ashraful, he asked me one question. I could not give a better answer to them. So his question was like this: suppose x square minus 2 x plus 3 is there, okay? So there may be more than one solution, okay?
Yes,
So
sir.
how we are going to deal? Because we are going to find only one solution here, okay?
Yes, sir. Oh, sir, numerical method will only give one solution, right, sir?
Yes, actually they are going to give one solution in mixing of the cases, okay? But and also there are limitations for each and every method, okay? You can check all those limitations, okay? Just let me tell a few things, and obviously your theory class is there to explain all those things.
Yes.
But for my satisfaction, what I am teaching, my students are learning that one, I am explaining everything, okay? So some specific condition is there, okay? Based on that condition, I will be able to determine whether my solution is going to converge or not, okay? Converge or not, okay? So even if the solution converges, then we can tell whether it will be more efficient or less efficient. Then we can determine, okay, by the code, okay? But whenever I am going for solution, normally it gives one specific solution, okay? But for any equation like this quadratic equation, I can guess that there is 2 solution, okay? 2 solution I can guess. But many equations are there. For that I cannot even guess how many solutions are there, okay, for some nonlinear equations. Suppose, can anyone tell how many solutions are there for e to the power minus x minus x? Can anyone tell? Can anyone tell? So there will be one solution, okay? So this is more or less solved, okay? But whenever x square minus 2, there will be 2 solutions, okay? So it probably is not going to work. Now, just wait. Now suppose 2 plus cos x plus cos 4x is going to give no solution, okay? On the other hand, 2 cos x plus cos 5x, okay, that's going to give infinite number of solutions, okay? So So even it's tough to determine how many solutions are there. On the other hand, it's more tough to find all the solutions. Okay, so in general, all the examples that we are going to deal with, they will be of one solution. Okay, so I am done almost. So is there anyone who has any queries till now? Hmm?
No, sir, no queries. It's focused.
So,
Okay. Yes, please. Maranaba.
so how are you going to submit? Are you going to screenshot the graphs and change it to
What?
PDF? I mean, are we going to screenshot the graphs, then make it PDF and submit all?
For your assignment?
Yeah, the lab
Oh,
report.
yeah. Just you can see there are two tasks. Okay, as you are supposed to do it in the lab, you will try to do it at your home. The problem that I was telling, that problem is there. Probably from here, Tasmin was mentioning time and again.
Yes, sir.
So after that, there is lab report. You will do these two. Okay, and you will write the code, make a PDF of all the codes. Okay,
So only the
and
codes, right?
also input and output. Or
Okay.
just make one PDF where your code will be there, your input output cards will be there. Okay, so that I can understand that all these things are there. Okay.
Okay, sir. No problem.
Okay, I'm done.
Thank you, sir.
Okay,
So, sir,
thank you for your
the
time.
fixed point iteration is the only thing we have to write by ourselves, and the next
You
one
can
is just
see.
Newton Raphson.
I don't know what's there. I cannot
Oh,
figure
okay,
it.
okay.
You can do it for yourself. Okay. So
Oh,
everyone, write your student ID again. After writing your student ID, you can leave. Write your student ID and leave.
I missed the initial attendance, sir. 314, sir. Okay.
Yeah, no problem.
Okay. Thank you, sir.
So,
Now,
Please.
sir, we
Yes,
need
please.
to write the IDs again.
Please write your student ID and you can leave. Okay.
Okay,
In
sir.
the chat
Thank you.
section, if you write, then I will consider your attendance. Okay. Because some
now,
people may be there who will be just enjoying throughout and at the end
Sir,
and at the beginning.
sir, can you upload the video today? I want to go through it. We want to go through it.
Please.
I mean, can you upload the video today so that we'll go through it and understand more?
Oh. Okay, I will try inshallah.
Okay, sir. Thank you.
Okay. Write your student ID and you can leave. Walaikum assalam. Write your student ID and you can leave. 334. 334.